I think a lot of it really comes down to network optimization.
Okay.
And if you look at it, I'll talk about the GSM path for a second. Obviously, there's only 2 operators there, and they're already off the table. But if you look at it on a global basis, there's so much that the HSPA, 2G, 3G operators can do to get additional capacity in their network without getting more spectrum.
Yeah.
You know, part of it's a device strategy. If you look at, I was talking to Telstra as an example, they've claimed that they've basically doubled the capacity capability of their network just through a technology migration on HSPA. So day one when they launched Release 5, HSPA with devices that only supported 3.6 megabits per second. Fast forward that to today where they're launching dual carrier with advanced receiver capabilities. They basically doubled the capacity without deploying new cell sites, without deploying additional capacity. So that can go a long ways.
Well, I think the other piece is, I think it allows you opportunity for smarter infrastructure because there's also laws of physics. I mean, on these devices, there's so much you can transmit on the uplink, and how far you can be, right? So you can't be 10 miles away and be transmitting 20 megabits with a 20 megahertz LT signal. You've got to get closer and closer. So that demands also to have smarter infrastructure, picocell, distributed antenna systems that allow you to now build cell site infrastructure that are easily deployable, faster deployable, and high capacity. And we call in our company something called inside-out network technologies, meaning that the network is going from the inside out for broadband. People are using it more indoors, where you have the need for a picocell-like infrastructure or a DAS distributed antenna structure. That's where people are congregating. That's where they're using the data. And then you go to the outside. So you've got to build it smarter. So just blanketing every cell site with an LT radio, you could design it, to your point, on optimize HSPA and then build LT where you have that data command. If you look at traditional cell site infrastructures, the build-out times are 24 months to get some of these macro sites up in the air. And if we can do these picocells in 6 months, 9 months, that's a huge saving right there in terms of time to get to market to the customer. And I think that's some of the challenges we've seen with some of the 4G networks that have been taking a long time to come out. But they're still faster than 3G, which took much longer.
Yeah.
And I think the need is now for innovative products that can be rolled out much faster. The devices are rolling out at a much faster pace. Networks aren't keeping up. I think that's the fundamental challenge right now, is that you have the new iPad coming in, 6 months later is a new one, right?
Yeah.
And the data crunch keeps stepping up.
Yeah.
One of the things with the heterogeneous network, HetNets, is how you make everything kind of work together, because you have low power, small cell, picocells working with big cells, macro, high power, and so there's challenges there.
Yeah.
They have to be addressed in how you make sure the device is connecting to the right network. Is it going to Wi-Fi? Is it going to a femtocell, a picocell, the macro? And that's based on all kinds of things, and that's where kind of the LTE advanced standard comes in and helps solve some of those issues as far as where should this device be to really optimize my network. And I think the challenge too is as you go from HSPA plus or HSPA to LTE, yes, you get more capacity to some extent, but that capacity quickly gets sucked up.
Yeah,
so if you get somebody a fatter pipe, you go from watching YouTube to Netflix.
Yep.
And so you actually, in some way, lose.
Yeah.
And that's the challenge as well. So I think operators need to think about, especially with mobile video.
Yeah.
Because that is the killer. That's 2/3, of the traffic or whatnot. Or 50% today going to 2/3 a few years from now. The operators can't afford to let people watch Netflix over their mobile phone.
Yes.
It's just the economics do not work out. But they kind of caught themselves in that they were offering unlimited data.
Yeah.
People got used to expecting that as a service, and Sprint still, I guess, kind of does in a way.
On their other handsets,
So people started to expect that.
Yeah.
So I think you'll see new billing and new business plans being introduced that will not be so much based upon how much data I use, but the service that I'm being offered.
Ultimately, they're going to go to the shorter cell, meaning a Wi-Fi cell or a picocell, and then you need large transport networks to help you transport that, because the cells are going to get smaller and smaller, and your wireless connection to afford that on your device is going to be the shortest hop that you can get onto a broadband network, right?
Yeah.
A fiber network, basically. Yeah. So that means that wireless network will become smaller,
yeah,
but they will have more wireless nodes.
Yeah.
So the complexity on the network management side and on the software side becomes an issue, because now you can assume you can have your personal picocell, personal device, that's your equivalent to your handset.
Yeah.
But if you go to that model, then I think you can do Netflix on that. So this is why I think Sprint with the Clearwire assets can leverage that. AT&T adding T-Mobile leverages that. I think Verizon becomes having a lesser spectrum, but they've got to come up with a strategy to optimize that spectrum better.
Yeah.
So I think part of the issue is spectrum optimization could be a big issue.
Yeah.
Because when I look at the spectrum, when we add more carriers in a sector, we do it based on the hottest sector. Not every sector is using that spectrum. So when you think about spectrum sharing, there could be opportunities where operators may be able to help each other.